Hello everyone, welcome to my YouTube channel. In this video, we are going to see some more questions from forces and resultant force. The first question is, if two equal forces of magnitude P act at an angle theta, the resultant will be option A, P cos theta by 2, option B, 2P sin theta by 2, option C, P sin theta by 2, option D, 2P cos theta by 2. We know that the resultant force is calculated from the equation R is equal to square root of P square plus Q square plus 2PQ cos theta. Here the magnitude of both forces are same. So substituting these, we'll get R is equal to square root of P square plus 2P into P cos theta. Simplifying, we'll get R is equal to square root of 2P square plus 2P square cos theta. Taking the common factor 2P square, we'll get R is equal to square root of 2P square into 1 plus cos theta. 1 plus cos theta is equal to 2 cos squared theta by 2. It's a trigonometric relation. So we'll get R is equal to square root of 2P square into 2 cos squared theta by 2. And simplifying, we'll get the answer as R is equal to 2P cos theta by 2. Therefore, the correct answer is option D. If two equal forces of magnitude P act at an angle theta, the resultant will be 2P cos theta by 2. The next question is, two forces are acting at an angle of 120 degree. The bigger force is 40 Newton and the resultant is perpendicular to the smaller one. Then the smaller force is option A 20 Newton, option B 40 Newton, option C 80 Newton, option D none of these. Okay, first we need to draw the diagram. Okay, we know that two forces are acting at an angle of 120 degree. Let these two forces be P and Q, and let the smaller force be P. Okay, then Q is equal to 40 Newton, and the next statement is that the resultant is perpendicular to the smaller one. So draw the resultant perpendicular to the smaller one. Okay, so we know that the angle the resultant makes with the first force is given by tan alpha is equal to Q sin theta divided by P plus Q cos theta. Okay, then substituting the values for corresponding variables, we will get tan 90 is equal to 40 sin 120 divided by P plus 40 cos 120, because alpha is equal to 90 degree as the resultant makes an angle of 90 degree with the first force P, and then theta, the angle between the two forces, is 120 degree, and the magnitude of Q is 40 Newton. Okay, so simplifying, we'll get infinity, because tan 90 is equal to infinity, and infinity is equal to 40 sin 90 plus 30 divided by P plus 40 cos 90 plus 30, because 120 can be written as 90 plus 30. Okay, now applying the reduction formulas in trigonometry, we will get infinity is equal to 40 cos 30 divided by P plus 40 into minus sin 30, because sin 90 plus 30 is equal to cos 30, and the value of sin is positive in the second quadrant. Therefore, it's positive cos 30. And similarly, cos 90 plus 30 is equal to minus sin 30, because cos is negative in the second quadrant. Okay. So if we have 90 or 270 degrees as the first angle here, then sine will become cosine, cos will become sine, etc. That means the trigonometry function will be the corresponding co-function. Okay, you can learn more about that in reduction formulas in trigonometry. Okay, then in order to satisfy this equation, the denominator should be equal to 0. Okay, so that P minus 40 sin 30 is equal to 0, which means that P is equal to 40 into sin 30. Now value of sin 30 is equal to 1 by 2. Therefore, P is equal to 20 Newton. Therefore, the correct answer is option A. Now the next question is, two forces 6 Newton and 8 Newton acting simultaneously at right angles to a point. The resultant is option A 12.8 Newton, option B 14 Newton, option C 12 Newton, option D 10 Newton. We know that the resultant is given by the equation R is equal to square root of P square plus Q square plus 2 PQ cos theta. Now in this question, angle between the two forces, that means theta is 90 degree. So substituting the value of theta, we will get R is equal to square root of P square plus Q square plus 2 PQ cos 90 degree. Cos 90 degree is equal to 0. So simplifying, we will get R is equal to square root of P square plus Q square. So if any two forces act at an angle 90 degrees to each other, then we can use this formula. That means R is equal to square root of P square plus Q square to solve. Okay. Now solving, we have P is equal to 6 Newton, say, and Q is equal to 8 Newton. Therefore, the resultant is equal to square root of 6 square plus 8 square is equal to square root of 36 plus 64 is equal to square root of 100, which is 10 Newton. Okay, now if you see that 6, 8 and 10 is a Pythagorean triplet. Okay, which means that 6 square plus 8 square is equal to 10 square. Similarly, other Pythagorean triplets are 3, 4, 5 and 5, 12, 13, etc. Okay, so these are some common values that is asked in the questions. Okay, if we have 3 and 4 as the forces, then 5 will be the resultant force. Similarly, if 6 and 8 are the forces, then 10 will be the resultant force. And if 5 and 12 are the forces, then 13 will be the resultant force. Okay. The next question is, the resultant of two forces is equal to P and acting at right angles is option A, P divided by root 2, option B, P divided by 2, option C, P divided by 2 root 2, option D, root 2P. Okay, we know that when two forces act at 90 degree, magnitude of resultant is given by R is equal to square root of P square plus Q square. Here Q is equal to P because the two forces are equal. Therefore, R is equal to square root of P square plus P square is equal to root 2 into P. Therefore, the correct answer is option D. The resultant of two forces is equal to P and acting at right angles is root 2P. Now the next question is, the resultant of two forces when acting at right angles is root 34 kilogram and when acting at 60 degree is 7 kilogram. The forces are option A 1 kilogram and 4 kilogram, option B 2 kilogram and 3 kilogram, option C 3 kilogram and root 5 kilogram, option D 3 kilogram and 5 kilogram. Now we have two cases. The first case is that two forces are acting at 90 degree, so that P and Q are acting at 90 degrees and resultant is equal to root 34 kilogram. In the next case is that if P and Q act at 60 degree, then the resultant is 7. So from the first case, we have applying the equation R is equal to square root of P square plus Q square. We have R1 is equal to square root of P square plus Q square. R1 is equal to root 34. Therefore, root 34 is equal to square root of P square plus Q square. Squaring both sides, we will get P square plus Q square as 34. Okay. Then, if we see the second case, we can apply the equation R is equal to square root of P square plus Q square plus 2 PQ cos theta. Substituting the corresponding values, we will get R2, which will be the resultant of the second case, is equal to square root of P square plus Q square plus 2 PQ into cos 60 degree. Cos 60 degree is 1 by 2. So that we'll get the equation as 7 because R2 is having a magnitude of 7. 7 is equal to square root of P square plus Q square plus 2 PQ into 1 by 2. Okay, simplifying, we will get simplifying and squaring both sides. We'll get 49 is equal to P square plus Q square plus PQ. Now we already know that P square plus Q square is equal to 34 from the first case. Substituting the value of P square plus Q square, we'll get 49 is equal to 34 plus PQ, which means that PQ is equal to 49 minus 34 is equal to 15. Okay. Now the possible values of P and Q are the factors of 15 actually. Okay. Factors of 15 are 1 and 15. So we can have either P is equal to 1 or P is equal to 15, and correspondingly Q is equal to 15 and Q is equal to 1. But if we see the options, no such options are available. Therefore, we need to see other possibilities. The other possibilities are other factors of 15, which are 3 and 5. Okay. So we have 3 kilogram and 5 kilogram as an option. Therefore, the forces are 3 kilogram and 5 kilogram. Therefore, the correct answer is option D. Now the next question is, if a force of 40 kilogram is acting opposite to two forces of 30 kilogram and 20 kilogram on the same line, find the resultant force. Option A 10 kilogram, option B 90 kilogram, option C 50 kilogram, option D 30 kilogram. Now we already know that if forces act on the same line, then we can simply add or subtract the magnitude of forces. Okay, we need to add the forces if we are considering the forces to be acting parallel or in the same direction as the reference force. Okay, so in this question we are going to take the reference force as 40 kilogram, and then 30 and 20 will be acting in opposite direction. So the resultant force will be equal to 40 minus 30 plus 20, which will be equal to minus 10 kilogram. So the correct answer is option A. But here it is negative, which means that the resultant is acting in the direction of 30 kilogram force or 20 kilogram force, and it acts in the opposite direction of 40 kilogram. Okay, so the correct answer is option A. Now the next question is, a force of P kilogram makes an angle theta with the horizontal, then the magnitude of horizontal component is option A P sin theta, option B P tan theta, option C P cosecant theta, option D P cos theta. Now the process of splitting up the given forces into a number of components without changing the effect on the body is called resolution of a force. Okay, if we have a force, we can split it into many components, but generally we split it into two mutually perpendicular components. Okay, and this process is called as resolution of a force. Okay, if we are splitting up into two mutually perpendicular components, then the horizontal component is Px and the magnitude is given by P cos theta, and similarly the vertical component is Py and the magnitude is given by P sin theta. Okay, horizontal component of force Px is equal to P cos theta and vertical component of force Py is equal to P sin theta. Therefore the correct answer is option D. A force of P kilogram makes an angle theta with the horizontal, then the magnitude of horizontal component is P cos theta. Okay, now the next question is, the normal component of a force inclined through theta degree is obtained by multiplying the force by option A sin theta, option B cos theta, option C tan theta, option D sin theta cos theta. We have seen that a force can be split into many number of components. Generally we split the force into two mutually perpendicular components. Now if a force acts on a surface or a curve, we can split it into two components. One is the tangential component and other is the normal component. Tangent is a line that intersects this curve or surface at just one point, and normal is the line that is perpendicular to this tangent. Okay, now applying the resolution of force, we know that the horizontal component, okay, or the tangential component is P cos theta and the normal component is P sin theta. Now another thing to note that this tangential component cannot always be horizontal because it can have any direction. The only thing is that it is parallel to the tangent at this point. Okay, so the tangential component of force Pt is equal to P cos theta and the normal component of force Pn is equal to P sin theta. Therefore the correct answer is option A. The normal component of a force inclined through theta degree is obtained by multiplying the force by sin theta. Now the next question is, The algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. This is known as option A, principle of independence of forces, option B, principle of resolution of forces, option C, principle of transmissibility of forces, option D, none of these. If a number of forces act at a point O, then by applying resolution of force, we can split each force into horizontal and vertical components. Okay, and then we can find the resultant from the principle of resolution of forces, which means that the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of the resultant in the same direction. Okay, now if we add the corresponding components of the number of forces along the horizontal direction, then this sigma h, which is the sum of the resolved parts of a number of forces, is equal to the resolved part of the resultant force. Okay, this is known as principle of resolution of forces, and therefore the correct answer is option B. The algebraic sum of the resolved part of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. This is known as principle of resolution of forces. Now, principle of physical independence of forces states that if a number of forces are simultaneously acting on a particle, then the resultant of this force will have the same effect as produced by all forces, which means that the effect of a number of forces will be same as that of the resultant. Okay, then principle of transmissibility state that if a force acts at any point on a rigid body, it may be considered to act at any other point on the same line of action. Okay, and the condition is that this point should be rigidly connected to the body. So principle of transmissibility means that a force can be moved along its line of action. Okay, and then even if we move a force along its line of action, the effect of this force will be the same. Okay, now the next question is the resolved part of the resultant of two forces inclined at an angle theta in a given direction is equal to option A, algebraic sum of the resolved parts of the forces in the direction, option B, arithmetical sum of the resolved parts of the forces in the direction, option C, difference of the forces multiplied by cosine theta, option D, sum of the forces multiplied by the sine theta, option E, sum of the forces multiplied by tan theta. Okay, now we have seen that from principle of resolution of forces, the algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of their resultant in the same direction. Therefore, the correct answer is option A. The result part of the resultant of two forces inclined at an angle theta in a given direction is equal to the algebraic sum of the resolved parts of the forces in the direction. Now, the difference between algebraic and arithmetical sum is that in algebraic sum we consider whether it is positive or negative, because if a force acts in one direction and another force acts in opposite direction, then we need to consider the second force as negative and first force as positive. Arithmetic sum means that we will not consider the sign, we just consider the magnitude. Okay, now the next question is, if a number of forces are acting at a point, then the resultant is given by option A, sigma v square plus sigma h square, option B, square root of sigma v square plus sigma h square, option C, sigma v square plus sigma h square plus 2 sigma h sigma v, option D, square root of sigma v square plus sigma h square plus 2 sigma h sigma v. We have already seen that we can apply principle of resolution of forces to find the resultant of a number of forces acting at a point. We can find this resultant by using this equation, R is equal to square root of sigma v square plus sigma h square, because we have seen that if two forces act at 90 degrees, then the resultant will be equal to square root of magnitude of the first force square plus the magnitude of the second force square. Okay, here the first force is sigma v, which is the sum of the components of this number of forces in vertical direction, and similarly the second force is sigma h, okay, which is the sum of the components of the number of forces in horizontal direction. Okay, therefore the correct answer is option B. If a number of forces are acting at a point, the resultant is given by square root of sigma v the whole square plus sigma h the whole square. Now the next question is, if a number of forces are acting at a point, the resultant will be inclined at an angle theta with the horizontal such that option A, tan theta is equal to sigma h divided by sigma v. Option B, tan theta is equal to sigma v divided by sigma h. Option C, tan theta is equal to sigma h into sigma v. Option D, tan theta is equal to square root of sigma h plus sigma v. Okay, we have seen in earlier discussions that if two forces act at 90 degrees, then the angle between the resultant and the first force is given by theta is equal to tan inverse sigma v divided by sigma h. Or we can say that tan theta is equal to sigma v divided by sigma h. Here theta is the angle that the resultant makes with the horizontal force. Okay, so the correct answer is option B. If a number of forces are acting at a point, the resultant will be inclined at an angle theta with the horizontal such that tan theta is equal to sigma v divided by sigma h. Okay, that's all in this video. Thank you.